Okay, welcome to our first set of notes. This is notes on the scientific method. So what you need to do to start out is title this page in your notebook. Okay, this goes into your notebook. Title it Scientific Method. Make sure the page is numbered. Put today's date on there. And don't forget to, at some point, go back to your table of contents and add it into there. And one of the key things I want you to think about while we're doing these notes is that you can always pause to write stuff down and then start back up again. So you can go at your own pace. You can go back and rewatch it. You can also access the slides without my voice at any time through my website. So the other thing, too, to keep in mind, words that are underlined are going to be your key terms. So those are going to be the important words to make sure that you write down and define. All right, so we're going to get started here. So scientific method should be at the top of your page. We'll talk about the 5 steps in the scientific method. Observing, questioning, hypothesizing, experimenting, and concluding. All right, we'll go through each of these individually. You don't have to write anything down just yet. But I do want to make sure that you understand this idea that after you make your observation, you ask a question, you form a hypothesis, do your experiment, and then you either accept or reject that hypothesis. If you reject it, you go back, you change it a little bit, whatever you need to do, and then you redo the experiment. Sometimes we keep the hypothesis and change the experiment. It just depends on what's going on. I also want to make you guys understand that really it doesn't necessarily have to happen, these 5 things, in this exact order. Sometimes, you know, we make an observation and go straight to hypothesis. Sometimes it's not even an observation. We just ask a question. It just kind of, you know, materializes in our head. You guys have probably all had that happen. Sometimes we actually even experiment before we form a real solid hypothesis. So it really depends, but these are kind of the steps that are generally involved. So let's talk about observations. We use our 5 senses to gather information about an event or item, and this helps develop our curiosity. You know, when we observe something and we interact with it, we sometimes become more curious about it, and we want to know more about it. So observations help us to sort of get on the track of being scientists. Then we ask questions. So questions would be a key term. I'm going to write that down and define it. Our questions come from our observation and then lead to the experimentation. It's really hard to design an experiment unless you have a question in mind that you want to answer. There's really no point in doing an experiment on something if there's not a question to answer. So we need to develop that question, usually in some detail, in order to design an effective experiment to answer it. Then we form a hypothesis. Our hypothesis is an educated guess, and we usually write this as an if-then statement. If this little girl is swimming in shark-infested waters, then it's highly likely that she might get bitten. Okay, that would be probably a relatively legitimate hypothesis. Another good hypothesis would be if somebody knows how to use Photoshop, they can make this picture happen. Okay, so there's lots of different hypotheses that we can make about different things that we see, but we generally base our hypothesis on the observations we've already made and known information or information that we've gone and researched and found out ourselves. So information usually goes into this, and that's why it's called an educated guess. After we do our hypothesis, we can now do our experimentation, this planned procedure to test the hypothesis. So one of the key things that's important about science is the experiment has to be reproducible to be valid. If you do it yourself and you don't write down any of the steps and you don't write down any information and I can't come in and redo your experiment, then it's never going to be really validated. Other people need to be able to do it. They need to be able to repeat the steps you did and get the same results that you did. And we'll talk about what that leads to in a little bit. And when you design your experiment, you have these 3 things, and these are important. And I know these are underlined, but we're going to go ahead and underline them actually right now because they should be. They're important. The independent variable, the dependent variable, and the control. Okay? These are 3 things that are really important in every experiment. Independent is the factor that is changed. Think about this word independent. If you are an independent person, you kind of do whatever you want to do. You change your mind a lot, maybe. So the factor that is changed is independent. The dependent variable is what's being measured. This depends on this. Okay? Dependent really, I mean, yes, it changes, but we aren't changing it. The dependent variable changes based on the independent variable. Okay? So it depends on, the measurement depends on this independent variable. And then the control is a part of the experiment that we don't change at all. It receives no experimental treatment. So it's sort of our baseline. It's what we measure our results against. It's what we compare this dependent variable 2. And then finally, after our experiment, we can draw some conclusions. Does the data support our hypothesis? Can we make other predictions? Can we redesign the experiment? So this is a rat here that has been eating a lot of artificial sweeteners, okay, things that are in like diet soda to make it sweet, and this is a tumor. So there's probably some conclusions that you could draw from that information and from this experiment. Okay, so we draw our conclusions based on the results that we have and the other information that we know. And then we can put this all together, and there's this term, a theory, and most of you guys have probably heard this, you know, the theory of relativity, the theory of evolution. In science, a theory is that which we are most sure of, hypothesis that's been proven by repeated results. It means we've done a test over and over and over again, and we keep getting the same results. Now, at some point, it can become a law, but generally, with theories, there are still bits and pieces of it that we can change and we can amend as new information is learned, or we still don't really have every little bit of information to put into it to make it an actual law. Okay, so theories are still, in the scientific term, it is still that which we are most sure of, and it's been proven. So when we say Einstein's theory of relativity, it doesn't mean that we just sort of think it's something that occurs. We pretty much know that it's true, but there are still those sort of unknown bits and pieces out there. And so like you see down here, a theory can be changed in parts as new experiments are done and new evidence is uncovered. A theory can eventually become a law if we do discover those pieces. So I really need you guys to understand this idea that theory isn't just our best guess. It's actually what scientists believe to be true. So that wraps it up for this set of notes. I told you they were quick, they were easy. If you have any issues, please come see me in class, shoot me an email, let me know what's going on, because I know this was the first set of notes, and I want to make sure that you've got them all taken care of. So if you have questions, go ahead and shoot me an email. Thanks for watching.